Hey everyone, welcome back. Well, today we're going to do some stuff on Frankenstein here. What I've been thinking about and we're going to do a little work on is the shaft to chain conversion and getting the chain line straight. So I was thinking about it the other day that, well, this shaft here and how we have to get a sprocket on it. And I really thought I'd sussed it all out. I was planning it out in my mind and everything was great. Really clever idea. I was going to be able to have a detachable sprocket so you can replace it later on and everything. But came out and one or two little measurements and all that fell by the wayside. So plan B. We'll start on that and I'll show you what it entails. Here's the shaft out of the I think they call it the mid gearbox, something like that. It's the one, it's taking the drive from this end from the engine and it turns it to right angles to go down the shaft. Well, fortunately the bevel gear is on spline, so we're going to use these splines, and I do have a sprocket that will fit. This was cut up on a laser cutter, so it's more a mock-up than anything else. Now, the sprocket is going to need to be about here, I think, which is just, you know, close but no banana. But what we can do is we can take these splines here, you see they stand proud and they're the stop for the actual gear that used to go on here. So what we're going to do is we're going to turn these splines down to the same diameter, same major diameter as these splines. Now, because this is hard, and because it would be a terrible interrupted cut on the lathe, you know, the cutter would be going bang, 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 bang like that. What I'm going to use for this is a tool post grinder. Now, I didn't have a tool post grinder, so I have rented one from the Richards steam engine company. So let me go and show you that. This is the aforementioned tool post grinder, called tool post grinder because it mounts where the tool post would go and it's got a grinding wheel in it. I don't know about this belt out here, but I've looked at a couple of pictures and I don't see any with a guard. I'm sure you could make one, but anyway. So the idea is that the job gets turned in the lathe slowly, and this grinding wheel is then set in motion and moved in on the cross slide until you start working on what you're grinding. Now, I haven't done this before, so stand by for catastrophe. But from what I understand, we want to turn the job itself very slowly. So I've got this turned down to 64 RPM. And we're not going to have to move this because we're only going to take off a narrow piece that isn't even as wide as the wheel is. The other thing you've got to do is you've got to have them both turning in the same direction. So this turns clockwise, so I've got to have this turning clockwise. And the reason it does that is, if you think about it, if this is turning clockwise and this is turning clockwise as well, then at one point as that comes up, that'll be going down. So they'll keep rubbing like that. So let me stick that in there and then we'll see if this thing works. So I've got it chucked up, I've got the live centre in here, made sure we're clear to go in and out, lock the carriage down and everything like that. So, let's see if this works. Well, it's grinding, so let me press on and I'll bring you back when it's finished. Alright, that's just started to touch the other splines. You'll notice I put a towel in there. It suddenly struck me that all those sparks and things wouldn't do the waves much good if it was showering them with molten metal. So let's have a look, see what we've got. Oh, perfect. Okay, on to the next stage. Now I'm going to move the chain line this way. I've got some space to play with. In fact, I've got about ½ an inch. But in order to do that, I don't want to have a bolt head on this side. So what I'm going to do is, just like a lot of the BSA and other bikes, the bottom mounting there sometimes you'll see is a stud that's actually in here. It's not a through bolt. So I'm going to take a bolt, we'll chamfer both sides, I'll put the bolt in and I'm going to weld it in so that I have nothing sticking out on this side. The other thing I'm going to do is take this off, because we want the chain's going to go right here and I want this to come right down. I'm probably going to have to put a rubbing piece on here, but we'll get to that. But right now, just putting a piece on here, you see it sticks on that. So I'm going to be able to have the chain running where that is, and when I do that, we're only about ½ an inch out on that. Can you see the can you see the sprocket? We're only about ½ an inch out here, so that just needs to move. It's annoying, it's just going off the splines. So what I think I'm going to have to do is make up a collar. What I was thinking of doing, this is the actual gear that goes on there. So if instead of having the gear on the end of this, I had the sprocket, this collar would be well onto those splines and would just push that out. But I might make one. I haven't got round to thinking about that yet. So anyway, this is starting to look much better. It's much closer. So let me get this cut off and a stud put in there, and then we can actually maybe try it with a piece of chain to see where the lines are going to go. Now we're going to move the sprocket out. So I've made, this is all temporary, don't forget, just for us to find out exactly what's happening. So I've made 3 spacing pieces of the requisite ½ inch length. And we'll get these on so that we know the sprocket is on the line that we want it to be on. Now the eagle-eyed amongst you will notice that that's going to catch on there, so when we actually get finished we're going to need to have Michael, put it inside. Ugh. We're going to need to have bolts with thinner heads. Yeah, we need about I don't know, 1/16, maybe an 1/8 of an inch taken off them, or we'll get some mushroom cap ones. Okay, that's first steps. Right now it's a few days since I filmed the last little bit, and I've been thinking more and more about how to go from the shaft to the chain. Now my original thought, there's the shaft there, was this is where the sprocket needs to be. I was just going to cut a chunk out, going to move it over whatever it is there, move it over about 1 inch, because I've ground these off now, but they're stuck up, so the sprocket would go on as far as that, and I needed it to be there. So I was just going to cut 1 inch out, V the shaft and weld it up. But that idea was knocked down by a couple of people, because they pointed out to me that welding this shaft up, because I have a bearing here and a bearing here, and this, as you may remember, is all inside a housing, so they've got to be spot on to each other, wasn't going to work. So then I started to get into some more exotic ways of doing it. This was the first thing I thought of. I was going to make this piece up here. You see, it's got the, I should turn that round, I suppose. It's got the splines for here, then it would move the sprocket out, and then this piece would come along here. The sprocket would be welded onto this piece and it would all be slid on there. Well, of course, this bit here, the big problem with this was that this part was going to have to be able to slide over the spline. So this ID was going to have to be the same or slightly larger than the major diameter of the splines, which meant I would have had to make up some sort of collar, and that would have had to be 2-piece to go on there to fill the gap here. So that was sort of the way I was thinking. But then I thought, well, the problem with that is, of course, sprocket's going to be welded onto there. That's going to make it difficult, obviously, to change the sprocket, because instead of changing this sprocket when it wears out, you're going to have to make a whole new one of these. And also, cutting these internal splines wasn't going to be that easy. So I went to number 2, which was getting even more exotic, and was the one I mentioned that I thought of and then dismissed. And what I was going to do here, it suddenly struck me that main problem was, as I say, coming on this end, everything had to fit over the splines. So I thought, well, what if I turn this down so I can come on it from this end? That means that the piece with the splines can have a nice solid end, look, which will go right down to this ID. So it'll be thicker than where it would be over the splines. I was going to grind these down a bit more so that this was a longish, thick piece. Then, also, the sprocket, instead of having to be around those, its ID would be on this round piece, and it wouldn't have to have splines on. I could just cut the centre out because it would be on there. So the idea was to make it in 3 pieces. This piece here, which, as I say, is going on from this end, would slide onto the splines and go up to there and have this nice solid end to it. Then the sprocket, then a collar, which again would be able to slide onto here and be a nice fit. Then I decided that if I did it that way, you see, because I had solid metal here and here, I could drill and put pins in. And if I used 3/16 inch pins, they gave me the same cross-sectional area as the splines did. So this would slide on, it would have its pins in it, then the sprocket would go up onto the pins, this would go up onto the pins, and then when the bearings were on and everything, because this is for a snap ring, a circlip sort of thing, and the nut on that end, it would all be held together and you could change the sprocket. Well, again, this was a lot of work, and I got thinking about it and thinking about it and thinking about it. So in the end I thought, I'm going to go back to my first plan. So I bought another one of these. Well, I had to buy the middle gearbox, because even in the parts book it just lists it as one unit because it's all shimmed up and things. So, but I found they were cheap enough. There was plenty of them around. I got one for $50. So, and I came back to my original idea of shortening the shaft, but in a different way, or in a way which I hope will do away with any chance of distortion in the shaft. Let me make sure you're still in sight. Yes. Okay. So what I'm going to do is put the shaft in the lathe, and this is a bearing surface, and this here is a bearing surface. So I can put it in, and I put a gauge on it and make sure that it's running exactly true in the lathe. Then I'm going to drill right through it, 1/2 inch basically, then ream it to make sure it's exactly the right size. Then when that's done, I can cut it in 2. I'll actually put some marks on actually here, so that I make sure that it's absolutely lined up. That way if there's a slight bit out in this through hole, it'll still be lined up nicely. So then I'll ream it to an exact size, and I bought some 4140. This hole's going to be basically 1/2 inch. The 4140 I got 5/8, so that when this is reamed I can turn that down to be the exact size, to be a nice press fit on this. So when I've got this out, I'm going to cut that in two and take my inch out. I then don't need to grind these off, because the sprocket, I can put the sprocket in exactly the right place and it'll be up against there, and then just a spacing piece and the nut bearing and the nut goes on, everything's fine. Now you'll see the centre core that I'm putting in sticks out a little bit at each end. It's not much, it's about 1/8, and I've got the space there for it. So I'll put it all together, put it back in the lathe, make sure these two bearing surfaces are still exactly right. Everything is parallel and straight and true. Then I'm going to weld up each end. Now that'll be an annular weld, it'll be going around there. So I don't think it'll exert any forces, any bending forces on this. And certainly I think if I tack it up each end, a couple of tacks, 3 tacks, 4 tacks, and then maybe weld it up together, that should hold all that. Back in the lathe, make sure everything is true. And then we'll weld up the 2 halves. Then if the worst comes to the worst and this is slightly out, what I plan to do is turn the bearing surface down a little bit to get us exactly true again, and just change the bearing. That can be done. That's no great problem, I don't think. And I think doing this way, I shouldn't get any distortion. Now what this will require me doing, and actually I would have had to do it anyway, is shortening the case it goes in. Well, the case, funnily enough, comes along and goes in just about here. So I was going to have to cut a piece out of it for where the sprocket goes, because there wasn't a big enough diameter inside. So that was going to have to happen anyway. So what the plan there is, I will cut a piece out of the centre of the casing, build everything up around the shaft, and there's bolts that go right through the casing. Bolt it all up so that everything's nice and this spins, and then I'll re-weld the case back together again. And then we've got to do a couple of little jobs. But anyway, this is the plan, and if the worst comes to the worst, that can go in the scrap bin and we'll come back to doing something on this. So I thought I'd explain all that to you, and now we've got some machining to do. Right, so I've mounted the new shaft I bought in the chuck, and I've set this up on this outer bearing surface, and yeah, you should be able to see it. As you can see, that's spot on. So what we're going to do is we're going to drill a 5/16 hole through there, and I've got a longer 5/16, and then we're going to go to 1/2 inch, and then as I say we'll ream it after that. So let me get on and do some holes, and then we'll come back. Now I've got this drilled all the way through, and I drilled it 1/2 inch and then I reamed it slightly over that. This end actually is hardened, so of course to get the hardening in this, it had gone into the ends. So I drilled all the way through to here, and then this last about 1/8 of an inch just would not go. So I had to use a carbide drill to open that out. And then what I did was I used, I put it in the lathe, put the bar in and just took a little bit out, so that when I put the ream through from this end, I didn't blunt the ream when it got to the hardened part. So we can deal with that. So I've got some 4140, I got 5/8, so that when this was finally reamed I could measure it, and then I'll turn this down to the exact right size to make this a sort of shrink fit. So we'll make it about a thou or so, because this is 1 inch here. So general rule of thumb for sort of shrink fits is a thou per inch. So we'll give it about a thou. Now, next thing to do is to sort of mock this up using the other one and find out how much I need to shorten this, and then I'll put it in the lathe and cut a piece out the centre with a parting tool. Now when I put this back together, as I say, the rod is going to go through it, so I'll weld it at each end, and I was going to weld it in the middle, but all the time I'm trying not to get any distortion in this. So then I thought what I would do, might put a few little bits of weld in, but basically I'm going to make a mechanical connection. This is the same size as that, same size hole through the centre. So what I'm going to do is machine the ends like so, with a nice tight fit, and then when that's together, so now instead of just a weld, we're going to have these joints here. As I say, what I might do is just put a little bit on each end. I don't know yet, I haven't quite decided. But anyway, we're going to machine these edges to be like that. So that's the next stage, to cut this and machine those into each end. Before we get started, I want to show you the view from my front porch when I got up this morning. See what I do for you chaps? I had to get the cats out, harness them up to the sled and mush my way up to the workshop. So anyway, let's get started. So here's the shaft cut in two, with enough space, fortunately, at each end to get the 1/4 inch that I need for the mechanical joint. Now I don't know if you'll be able to see this, but I also put a couple of marks on before I cut the piece out, so that I could line it up when I'm reassembling it, and of course when I cut the doodads out. The reason I did that was, although I am pretty certain that everything is exactly true, that's how it was when I ran the ream through it. So if there's any variation of the line of the hole that goes through, that should be it. So when I put the centerpiece in, it should go in exactly right. So what we're going to do is put those into the milling vise and get it set up. Here it is in the vise. So what I'm going to do is use that to get this completely level using the test indicator. Then I'm going to find the center, and then I'll zero it on the DRO, and the first thing we're going to cut is this piece. Now this one's easy to do because all I do is, when I've got it centered, I go backwards and forwards, and that cuts this slot, go back to my center, go side to side, and that cuts that slot. So that one's easy. Then when that's done, I'm going to take that out, put the other piece in, and go through centering it and everything again. Now I could use a stop and all the rest of it, but I want this to be spot on, so I'm going to recenter it. Then I need to cut this, and this one, you see, I've got to cut these out. So I'll be on the center, so I've got to work out how much I'm going to go across to get this line, the vertical line, and how much up to get that line, and then I'll cut those 4 pieces out, making sure that I use a datum for that little scribe mark I put on, so that I can put them all in, and hopefully when that's done it'll all go back together nice and tight and straight, so that when I turn the piece to go down the center, it'll all line up exactly right, and our bearing surfaces will be all completely parallel with each other. So let me get stuck in. I'll get it set up and then I'll bring you back when I've got the milling cutter in. Now we're all set to go. Everything's square, this is centered. I've touched it off on this edge here. I've got a carbide bit in because the shaft is hardened. When I was using the parting tool, it sort of was working hard for a little bit and then it just went through the rest of the steel. So let's see what we can do here. Zeroed this out, so we'll do it in 2 cuts, I think. Let's see anyway. Maybe you can hear the change in the sound there. And there we have our first half done. So I'll get all set up. I'll show you how I'm going to work out doing the other bits, but then I'll probably just speed it up again as I did with this last bit, because you don't want to sit there watching the milling machine go around. So let's set it up again. I thought the easiest way to explain these cuts was on a drawing rather than trying to show you on the mill. As you can see, I didn't go mad with this drawing. But there is our piece, basically a tube. There's the centre line that we get it on, and there's our end mill. So as I say, the first part is really easy. All we do is we go straight up like that, straight back down, and then we go across, and straight across from that centre point, and that gives us this. But now we want to mill out these pieces. So what we've got to do is move the cutter over. So what we want is we want to cut out this section here. Right? So we want this edge of the cutter actually now on this line, because we want it to go up there and cut that out. So we're going to move this over, because this is a 1/4 inch cutter, we're going to move it over 1/4 inch. So this line, if this is 0, this line is now actually minus a 1/4 inch. And this line here is going to be plus a 1/4 inch when we go over to do that side. And similarly here, we don't want to just cut straight up, we only want to be cutting on this line. So we're going to have to raise that up exactly the same. We want this cutting edge on this line, so that's got to go up there 1/4 inch again. So this line, right, is going to be plus 0.25. So what we're going to do is we're going to move the cutter until it's minus 0.25 on this axis and plus 2.5. So we're going to move it over to the right and then up, and then it'll be there. We'll cut that out, we'll cut this out, and we'll do the rest of it. Then I've got a 1/8 inch cutter that I'm going to put in to do that little bit in each corner. So let me get set up and we'll see if I can cut these corners out. So there it is. Finished off, pressed together. Now the big question of course is, have we still got these in line? So let's put it in the lathe and see what happens. Okay, let's see what we got here. It's round about 1 on this bearing journal. And about the same there. So I think once we've got our piece down the centre, we should be fine. Just out of interest actually, I don't know if you can see that poking in there. No, you can't. Let me pull you out. I say, I actually ran the ream down the centre and it went down perfectly. Didn't seem to catch on anything. And that's the one I reamed it with. So next thing to do is to turn the centrepiece.